Okay, so third time's a charm. This is my third time recording this. Hi, Miss Marcia. Today I'm presenting my research on additive and subtractive colors. So, additive primary colors are the primary color elements that make up white light. They are called additives because when you must add the colors together to create white light. The additive primary colors are red, green, and blue, commonly known by their acronym, which is RGB. As you can see in the picture, we have the red, green, and blue. Um, Additive primary colors are the primary colors of pigment that different systems apply to the colors that we see on computer screens, on printed images, etc. So right now we are enjoying the additive primary colors through our screen. So there's an essential feature of additive color mixing, which is that light of different wavelengths is added together. And to make this tangible, you can use two flashlights, or three, as you can see in the picture. All of these flashlights, they emit a white light. So what we're going to do is we grab a red flashlight, a flashlight, and we put some red foil on the flashlight, and this would create a red light. And then to the other flashlight, we add a green foil, and it's creating the green light, and we shine them together onto the same point on the wall, and then this would create later, uh, sorry, a yellow light. And if we add all the colors together, which if we add a blue foil to another flashlight, all of those colors would create white light. And as you can see in the picture, basically it's all about light. Additive primary colors, it's mostly about light. Then we go to the subtractive colors. So after we understand the additive color mixing, we can now deal with the subtractive color mixing. As a subtractive color mixture, we can understand the change of a color when it's passing through a medium. This medium is the color. So first of all, we can see that here we have cyan, magenta, and yellow. The acronym for these for the subtractive colors are CMYK, which the K represents the color key, which is basically black. So let's see, like for example, we have a sheet of paper. I don't have a yellow watercolor, but this is how it's in the experiment. And let's say that this is a normal blank paper, and I just simply colored it as yellow. So where we painted, obviously we will see yellow, and this yellow watercolor contains some pigments that only let a certain area of the color spectrum through. So let's say, yes, the color we see, it's yellow, and okay, so we see the color that it's yellow, and oh yeah, so it is important to understand that it is always a reflection of the available light, the color that we see. So I'm gonna turn on this lamp, and maybe, oh my god, maybe you can see that the light that it emits, it's yellow light. That's clear. And but if my room was dark, we would obviously not see that. So normally, let's say we can take a very bright available light, which is daylight, and if this daylight it's not, let's say it's not white, then we can see the yellow in any other like it could be a slightly different color if we didn't have that light. Okay, so let's continue. The secondary colors of additive color mixing are the primary colors of subtractive color mixing. So here we have cyan, magenta, and yellow, and these are the secondary colors of additive color mixing. With a subtracted color mixture, it is important to understand that subtracted, it is additive subtracts, obviously. So yellow and cyan stacked on top of each other result in the color green, and then cyan installed on top of magenta result in the color blue, and magenta on yellow, it's on red, and so on. So the subtracted color mixture is always used when we see something in nature, let's say. So seeing in nature also means that when we get a print out of an image, like we print out an image out of a printer, or we send like a photo to print, yes, a printer. So that result is always a result of the subtracted color mixing, regardless of the primary colors which with the print was resulted. So basically, RGB, additive colors, red, green, and blue, they consist of mixing light to create white light. And CMYK, which is cyan, magenta, yellow, and key, it's the subtracted colors, which mostly consists of mixing ink and then creating a black color. Oh yes, as I said before, I'm not sure if I said it before, but when all the three subtractive primary colors are combined, they produce black. Thank you.